So this is a video designed to help students who are struggling with question number 2 on the homework, homework number 6. So what we have here is we have a situation in which there are 2 point charges, one which is located at 1, 2, and the other which is located at 5, 2. And then we're looking at calculating the electric field along a line that is in between those 2 points. What we could do is we can select a single point and a single point along that line, and we can then determine what is the electric field due to each of those 2 charges at that point. Of course, the electric field is going to actually be pointing like this, and it's going to be pointing like this. We know that the distance r is going to be the same for each of these 2, and that distance r can be calculated. We can actually calculate r squared according to the Pythagorean theorem. We know that this is going to be this distance right here. So this distance along this line is y minus 2. And the reason why that's y minus 2, of course, is because this distance right here is 2. So r squared then is equal to y minus 2, the quantity squared, and then plus 4. So we know that this is well, technically I suppose this is 2 squared, because we know that this distance right here is also equal to 2. So we know that r squared equals the quantity y minus 2 squared plus 2 squared. And so we're able to do some important calculations based on our knowledge then of r. We also know that, of course, the horizontal components of these 2 electric fields are going to be equal and opposite each other, and they're going to cancel each other out, leaving only the vertical components, or leaving only the components in the y direction. This, of course, is the y direction, and this is the x direction. We're only left with the 2 components in the y direction, which we'll be adding together. So we know that E in the y direction, which of course is going to be a function of y, we know that this is the first E sub y as a function of y, plus the second E sub y as a function of y. We also know, furthermore, that there's an angle theta, and this is the angle theta right here, and we also know that E sub y1 is just E sub y1 is just E sub 1 cosine of theta. So this is equal to E sub 1 multiplied by the cosine of theta. And then, of course, we also have a second term that's identical to that. And so, in reality, this term and this term are equal, and so this is simply multiplied by 2. So we're able then to find the cosine of theta. The cosine of theta is going to be the distance of the adjacent side. So if this is theta here, then of course this is also theta here. And so we're looking for the adjacent side right here. That adjacent side is going to be y minus 2, and the opposite, or the hypotenuse, is going to be r. We remember then that r is y minus 2, the quantity squared, plus 2 squared. And so this allows us to calculate the cosine of theta as well. We can then combine those 2 together, and when we combine them together, we end up with an expression that is, let's see, we're going to have an E sub y1 and an E sub y2. We know that E sub y, let me put this down here, E sub y is going to be 2 times the charge q times the cosine of theta, and that's divided by 4 pi epsilon naught times the quantity y minus 2 squared plus 2 squared, and then since we can now calculate the cosine of theta, we can replace this as 2q divided by 4 pi epsilon naught, and then we're going to have we take up this, what we have this for the cosine of theta. This is times y minus 2 divided by the square root of y minus 2 squared plus 2 squared. But then there's also this term right here, which means that perhaps what we'd written here as the square root, we should actually not have a square root. We should just have it to the 3/2 power, because one half of the power comes from the square root here, and then the 1 comes from there, and what we're left with then is to the 3/2 power. And so we end up with 2q times y minus 2 over 4 pi epsilon naught times y minus 2 squared plus 2 squared to the 3/2 power. And that is very close to the final answer. The only thing to update is that we know that the magnitude of Q is, according to the problem statement, 2 times 4 pi epsilon naught. So 2 times 2 times 2 times 4 pi epsilon naught. That's a little confusing. That should be a 4. Divided by 4 pi epsilon naught, multiplied by the same y minus 2 over the square root, not square root. This is to the 3/2 power, y minus 2 squared plus 2 squared. The 4 pi epsilon naughts are going to cancel, and then we're left with a 4. 2 times 2 gives a 4, and this becomes 4 times y minus 2 divided by y minus 2 squared plus 2 squared to the 3/2 power. And so that gives the full solution of what the effective electric field is for those 2 points at any point. And notice that we really haven't specified over here what the actual value of y is, so y is valid along any point along this vertical line. This means that for the second part of this problem, you'd be able to go in and use MATLAB to be able to calculate that.